Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is CH3-C, ONA, is equal to CH2, which is the sodium enolate of methyl vinyl ketone, MVK, or equivalently the sodium salt of isopropanol, sodium isopropanoxide. It reacts with HCCH, acetylene, under the conditions shown. Moving on to the next step. The sodium enolate, CH3-C, ONA, is equal to CH2, acts as a nucleophile. Acetylene undergoes nucleophilic addition, vinylation. The sodium alkoxide adds to acetylene in a repeat-type reaction, giving CH3-C is equal to CH2-OCH is equal to CH2, isopropanyl vinyl ether. And for the final step, the vinyl ether CH3-C is equal to CH2-OCH is equal to CH2 undergoes acid hydrolysis. Vinyl ethers hydrolyze under acidic conditions to give an aldehyde ketone plus an enol. The vinyl ether hydrolyzes to give isopropanyl alcohol, which tautomerases to acetone and acetaldehyde, but more precisely the product is the mixed enol ether hydrolysis product. Actually, the vinyl ether ROCH is equal to CH2 on hydrolysis gives ROH plus CH3-CHO. So we get isopropanol, CH3-C, or is equal to CH2, which tautomerases to acetone and acetaldehyde. That does not lead to the answer. Let me reconsider. Step 2 revised, Reformatsky-Reppe reaction context, the sodium salt CH3-C, ONA, is equal to CH2, sodium isopropanoxide, reacts with acetylene. In base-catalyzed addition, the Carbanion enolate adds to acetylene to give CH2 is equal to C, CH3, OCH is equal to CH2, isopropanyl vinyl ether, after the sodium salt. On acid workup, H+, the enol ether hydrolyzes, the vinyl ether portion, OCH is equal to CH2, hydrolyzes to give off plus CH3-CHO equivalent, but the whole molecule is CH2 is equal to C, CH3, OCH is equal to CH2. Acid hydrolysis of this vinyl ether gives CH2 is equal to C, CH3, or isopropanol acetone by tautomerism and acetaldehyde. This still does not give AC5 diene. Step 2 re-revised, the sodium enolate of methyl vinyl ketone adds to acetylene. The enolate carbon, CH2 is equal to attacks acetylene, CH2 is equal to C, CH3, ONA plus HCCH product where the alpha carbon adds to acetylene, giving CH2 is equal to C, CH3, CH is equal to CHONA 1, 4 addition product sodium enolate. On H plus workup, the enol tautomerases, CH2 is equal to C, CH3, CH is equal to CHONA plus H plus CH2 is equal to C, CH3, CH2, CHO, 4-methylpent, 4N1-al. No. Corrected mechanism, the enolate oxygen of CH3-C, ONA, is equal to CH2 adds to acetylene giving CH3-C is equal to CH2, OCH is equal to CH2, isopropanyl vinyl ether. Acid hydrolysis, Claisen rearrangement is thermal, not acid. Under H+, vinyl ether hydrolyzes to give ketone, CH3, co-CH3, acetone, plus CH3-CHO. This still does not give C5 product. Final correct pathway, the enolate carbon attacks acetylene CH2 is equal to C, CH3-CCH, dehydration product after H+, giving 2-methyl but 1N3-ene. Then H2PD BaSO4, Lindlar type semihydrogenation, reduces the triple bond to CIS double bond, CH2 is equal to C, CH3, CH is equal to CH2, 2-methylabuta 1,3-diene is equal to isoprene. Then Al2O3 delta causes dehydration or isomerization. Isoprene on Al2O3 delta would not change much, but answer A is H2C is equal to CH3, CH3 is equal to CH2, which is isoprene. So the final product after Al2O3 delta is isoprene itself, or the Al2O3 step causes isomerization to give isoprene. Option A, H2C is equal to CHC, is equal to CH2, CH3 is isoprene 2-methyl-1,3-butadiene. This matches the synthesis of isoprene from isopropanyl acetylene via semihydrogenation, and the Al2O3 delta step may cause further isomerization confirming isoprene as product. Therefore, the correct answer is A. Therefore, the correct answer is option A.